tayo dito ang bagong project.
Ay, ano naman bagayaan?
Ito. Bago natin project.
Ano yan?
Ito. Ito ay tinatawag na constant current source using Zener Diode.
Ay, ano naman ang ano niyan?
Ba? Ang current niya ay constant. Kaya siya tinawag na constant current source.
Paano yan?
Aba, ay lagyan natin ng supply from adjustable power supply. Meron tayong tester. Nakakonekta sa output. Ito, supply. I-set natin sa 9 volts. Ayan. 9 volts na. Diba? Oh. Anong current? 9 milliampere. Diba? At yung LED, yan yung output LED natin. Umilaw siya. 9. And then, current consumption, 20 milliampere at 9 volts is equal to 0.171 watt or 171 milliwatt.
Ay, ano naman ngayon ang mangyayari dyan?
Aba, dagdagan natin ng LED. Isa pang LED. Ayun. Almost the same. Current, 9 milliampere. Dalawang LED. Ang current ay constant. Diba? Isa pang LED. Oh. Tatlo na ang LED. Ang current almost 9 ampere or yan, 9 milliampere. Tatlong LED connected in series. Still, the current is constant. Yan ang tinatawag na constant current source using Zener Diode. Here we have the circuit diagram of our constant current source using Zener Diode. We have the transistor BC547 NPN BJT type with emitter resistor of 1K and the collector LED, which is the output LED color red. And then we have this biasing resistor, at the same time a current limiter to the Zener Diode, which is connected to the base to the ground in a reverse bias condition or in a breakdown voltage condition. So Zener is connected this way with a 3.3 volts. It is known as 1N4728, a 3.3 volts pin out for the Zener Diode, connected this way. And then we have the pin out of BC547. We are supplying the 9 volts. What is the configuration of the transistor? It is a common emitter because the output is located at the collector to the supply. In order to function this transistor, we need to bias the base. And because of this clamp Zener diode, it receives a 3.3 volts voltage at the base, making this transistor to turn on whenever we power on the circuit. With the use of 1K as a current limiter resistor to our diode, at the same time as a voltage divider to the transistor. Since this transistor now works as a switch or sometimes as an amplifier, but in our case it works as an amplifier and at the same time as a switch. Why? Because in our example we are having this ammeter. We have the tester connected in series with the output. When we connected the LED, the transistor works because there's a voltage at the base. We just need a 0.7 volts in order to work the transistor, making the current to flow from 9 volts to the collector, to the emitter, and then to the resistor emitter. So, and what is the current? Current is constant, 9 milliampere. As we have seen in the tester. So, it works because of the clamping diode that has 3.3 volts. Voltage bias of 3.3 volts. And because of that, transistor output will conduct. Here, when we connect another LED in series, still the current is 9 milliampere and it is known as constant current. This is the symbol for the constant current, a circle with an arrow. And again, we connected another LED and still the current into the collector is 9 milliampere. The truth here is this resistor, which is a 1K, still at the 2.6 volts, peaks constant. The voltage at the base, which is here, base at the voltage, is still 3.3 volts. Constant voltage at the base and voltage at the emitter, 2.6 volts. While here, this is the variable collector to emitter. When we connect one piece of LED, it has a certain voltage of 3 volts, and then when we connect another one LED, we have now 2 LEDs. It has a certain voltage of, I think, 2 volts, and then when we connected another LED in series, 3 LED in series, it will now serve as a switch, 0.7 volts. I think that is the voltage across the collector to emitter. So the voltage across the collector to emitter varies. It means it is functioning as an amplifier at the same time as a switch. Because the current flows here, which is not actually the current, voltage at the base. Because these two are known as the voltage biasing of the transistor. These two components, the 1K and the LED. So it functions. The transistor operates because there is now a biasing voltage at the base to emitter, causing the current to flow from 3 LEDs and then collector to emitter, then the resistor. As long as the LED is, you can make the LED to turn on as long as there is enough voltage to turn this LED, because each LED has 2 volts, 2 volts, 2 volts, 2 volts, 3 LEDs, 6 volts, plus the voltage at the emitter is 8, and the remaining voltage is dissipated across collector to emitter. So this collector to emitter is the one that varies the voltage across collector to emitter, making this a constant current source using a Zener diode because the voltage across the base is constant, the voltage across the emitter is constant. Remember that if we have 9 volts here, if we have 3.3 volts here, we have 9 minus 3.3 volts is 5.7 volts across the 1K. But into the output, if we have 9 volts here, if we have 3 LEDs here, 2, 4, 6, 6 volts for the LED, and then plus the 2 volts at the emitter resistor, it is 8 volts. And the remaining will be dissipated across collector to emitter, making this to serve as an amplifier and then eventually become serving as a switch. Okay? Because if we connect 4 LED to the collector, from the BCC to the collector, 4 LEDs, there is not enough voltage to turn these 4 LEDs because we have 4 LEDs, each LED has 2 volts, and then plus which is equivalent to 8 volts. The 4 LEDs equals 8 volts plus the 2 volts at the emitter, which is constant. It making this a 10 volts. 10 volts, making this a 10 volts, which is not enough to turn on the LED because our supply is 9 volts. So we better vary the supply, making it at least 12 volts. In order to maintain, to turn on these 4 LEDs. So for the 9 volt supply, we just need 3 LEDs with a constant current of 9 milliampere. So the purpose of using this constant current source using Zener diode is to drive the LED, to serve as LED driver. LED must be connected in series. So that is the use of this constant current source using Zener diode. It will serve as the LED driver, the clamping diode to the biasing to the base of the transistor, making this transistor to work. As if there's if the base to emitter has a 0.7 volts, it will turn on the output side of the transistor, making the 3 LEDs to turn on. Remember, the collector to emitter is the one that varies. This is the one that the voltage is adjusted, depends on how many LEDs you are connected. And this one is constant. This one is constant. Same as here. Only the transistor. Now, that serve as an amplifier and sometimes a switch. In order to function this as a switch you need at least 0.2 volts. That would serve a transistor as a switch. While greater than 0.2 volts serve as an amplifier amps. So that is the constant current source using a Zener diode.